Hello everyone, Mr. Geiselhart here, and this video is going to take a look at sequences. You probably remember sequences from Algebra 2, but all it is a list of numbers that follows a pattern. The one thing about sequences that we really need to talk about is the term number and how we're going to do that. Well, in any sequence, we would say that this is the first term here. So this is the first term, this is the second term, and the third term, and so on. Now, the way we write that in math is we say that the first term we call a sub 1, the second term is a sub 2, the third term is a sub 3, and so on until you get to the nth term, which would just be a sub n. Like that. Now let's look at an example where we're given a formula for a sub n, or the nth term. So what we're going to want to do here is say if we want to find the first term, we would call that a sub 1. Then all I'm going to do is I'm just going to put a 1 in place of n each time, and then I'm going to solve it. So 2 times 1 factorial. So I do 1 factorial first. 1 factorial is equal to just 1, so that would be 2 times 1 on top over 2 to the first power. So that would be 2 times 1, which is just 2, over 2, which is equal to 1. So my first term would equal 1. Now, if I want to do my second term, I just put a 2 every place in where I see an n. So that would be 2 factorial divided by 2 squared. Now, when you solve this, you're going to end up with 2 times 2 factorial, which is just 2, over 2 squared, which is going to be 4 over 4, which is also going to equal 1. Let's see what the third term is. The third term is going to be 2 times 3 factorial over 2 to the third power. Well, remember, 3 factorial is 3 times 2 times 1, so that would be 6. So that's 2 times 6 over 2 to the third, which is 8. So that would be 12 over 8, which is equal to 1.5. Next, we want to do the fourth term. So that would be 2 times 4 factorial over 2 to the fourth power. When you're doing that one, you're going to do 2 times 4 factorial. Well, 4 factorial is 4 times 3 times 2 times 1, which will be 24, over 2 to the fourth power, which is 16. So 2 times 24 is 48 over 16, which is equal to 3. So my third term is 1.5. My fourth term is 3. And let's do one more. My fifth term would just be 2 times 5 factorial over 2 to the fifth power. So when you do this one, you're going to end up with 2 times. Now, 5 factorial is 120 over 2 to the fifth power, which is 32. So that would be 240 over 32, which ends up being 7.5, and that's going to be my next term. And you could keep going on and on forever with this. The next example we're going to look at is something called a recursive sequence. In order to do this, you have to be given one or more of the terms of the sequence and the formula for the sequence. So in this example, we have the formulas a sub n is equal to 3 times a sub n minus 1 plus 1, and where a sub n is, or a sub 1 is equal to 2. So if I want to list out the terms of my sequence, I'm going to just start with a sub 1 is equal to 2. Now, in order to find a sub 2, all I'm going to do is take 3 times a sub, now since n is 2, I'm going to put 2 minus 1 here plus 1. Well, what that really means is I'm going to do 3 times a sub 1 plus 1. So if I do that 3 times. Now, we already know what a sub 1 is. They told us that. A sub 1 is going to be 2. So I'm just going to put the number 2 in there plus 1. So we have 3 times 3, because 2 plus 1 is 3, which is equal to 9. So that means my second term is going to be 9. Now, to do a sub 3, I'm going to do the same thing. 3 times a sub 3 minus 1 plus 1. So that'll be 3 times a sub 2 plus 1, which is going to be 3 times, well, a sub 2 we already calculated was 9. So that's going to be 3 times 9 plus 1. So that would be 3 times 10, which is equal to 30. Now, let's try and find the fourth term. Now, you should be able to see the pattern here. When you see this a and then n minus 1, that just means the previous term. So what I'm going to be doing here is I'm going to say is that if I want to find a sub 4, I just have to take the previous term, add 1, and then multiply it by 3. So in this case, my previous term is 30. So I'm just going to take 3 times 30 plus 1, and that's going to be 3 times 33, which will equal 99. So my fourth term is 99. Then the same thing here. For my fifth term, I'm just going to take 3 times my fourth term plus 1. Well, my fourth term is 99 plus 1, so that would equal 3 times 100, which would be 300. And then you could keep going on with this pattern if you wanted. So the sequence given by this formula with this first term is just going to be 9, 30, 99, 300, and so on. Okay, we're going to look at another example. This is pretty much the same thing we just did, but it's written a little differently. The notation's a little different, but it's pretty much done the same. So if we start with the first term, which it's given to us as 1, notice that this says n plus 1 and this just says n. So what that means is to get my second term, I have to do a to the 1 plus 1. So in other words, I have to look at the first term or use 1, a sub 1, in my answer. So this is just going to be a sub 2 because 1 plus 1 is equal to 2. So now to find the second term, I put 1 in place of n. So if I put 1 in place of n over here too, I'll have negative 3 times a sub 1 plus 2. Well, we know what a sub 1 is. That's just going to be the first term, which is 1. So this will equal negative 3 times 1 plus 2. Well, negative 3 times 1 is negative 3 plus 2 is equal to negative 1. So my second term is equal to negative 1. To find my third term, I'd have to do 2 plus 1, so n would equal 2, and that would give me the third term. So that would be negative 3 times a sub 2. Because remember, now here my n is 2 there. So that means I'm going to put a 2 in place of n to get this 3 and a 2 in place of n there. So plus 2. So that'll be negative 3 times my answer from before, which is negative 1 plus 2. Well, negative 3 times negative 1 is a positive 3 plus 2 is equal to 5. So again, I'm going to do a sub 3 plus 1, which will give me my fourth term. So that'll be negative 3 times a sub 3 plus 2. So again, I'm going to take negative 3 times my previous term, which is 5, plus 2. Well, negative 3 times 5 is negative 15, plus 2 is negative 13. So that will be my fourth term. Now, you should be able to see the pattern. So a sub 5 is just going to be negative 3 times the previous answer, negative 13, plus 2. So that will be a positive 39 plus 2, which is going to give me 41. So if I were to write this out, I would have 1, negative 5, let me go back here. 1, negative 1, 5, negative 13, and 41. This is called an alternating sequence because each term alternates from positive to negative as you're going through and doing these, and that will continue. Okay, we're going to put kind of all this together and see if we can do this just by thinking about it instead of writing everything out, and that might make things a little bit easier. So in this one, we're given the first two terms. So a sub 1 is equal to 1, a sub 2 is equal to 3. Now, when I'm looking at this, this just means n minus 1 the previous term. So if I want to find a sub 3, that just means I have to take 2 times the previous term, which is a sub 2, and then I have to add that to the term 2 places ago, or 2 before this. So that would be a sub 1. So that's just going to be 2 times a sub 2, which in this case is 3. So my second term is 3, plus a sub 1, which is just 1. So that would be 6 plus 1, which is equal to 7. So now if I think about this in terms of the formula, really what I'm doing is I'm taking the term before it, multiplying it by 2, and adding the term before that. So in this case, it's going to be 2 times the term before it is 7, plus the term before that is 3. So that would be 14 plus 3, which is equal to 17. And then the last one we're going to do is a sub 5. That's just going to be 2 times my previous term, which is 17, plus the term before that, which is 7. So that will be 34 plus 7, which is equal to 41. So my sequence here is going to be 1, 3, 7, 17, 41, so on.